Bismillahirrahmanirrahim. In this session, we will discuss thermal properties and temperature related problems from section 2.2 of Heather Kennett book. At page 106, we have this problem. Let's start this one. Question number 1. If 25,000 joules of energy is supplied to a mass of 2 kilogram. The mass of is 2 kilogram, and the temperature rises from 10 degrees Celsius to 35 degrees Celsius. So a mass of 2 kg is supplied this much amount of energy for raising temperature from 10 degrees Celsius to 35, and calculate the specific heat of the mass. So we have given energy supplied 25,000 joules, mass of the material is 2 kg, and the temperature rise is 35 minus 10, that is 25 Celsius, and we have to find the specific heat capacity of the mass. So we have to find this C. So we have given this energy supplied is equal to mass into specific heat into change in temperature. So specific heat C is equal to delta E upon m delta theta. So this is 25,000 joules, and mass is 2 kg, and the temperature rise is 25 Celsius. So we, on manipulation, we have obtained this 500 joules per kilogram per Celsius. Is this the specific heat capacity of the mass? Specific heat capacity is 500 joules per kilogram per Celsius. And question number 2, how much energy must be supplied to a mass of 3 kg of material of specific heat capacity 500 joules per kilogram per Celsius to raise its temperature by 10 degrees C? So the delta theta is given 10 degrees C, specific heat capacity is given 500 joules per kilogram per centigrade, and the mass is 3 kg, and we have to find the energy required or energy supplied. It is a similar kind of problem. Here 25 degrees C increases, here in this case only 10 degrees C increases, so the much lower energy will be required. So MC delta theta, M is 3 kg, C specific heat capacity is 500 joules per kilogram Celsius, and the temperature rise is 10 degrees C. So this C will cancel with this 1 kilogram will cancel, and eventually on manipulation we will get this joules. So this is 5,000 and 3 is 15,000 joules. So this much energy will be required with this specific heat capacity of the material for delta T, 10 degree rise for 3 kg of mass. Now put this into practice on page 108. An electric kettle rated at 3 kilowatt. The rating of the electric kettle is 3 kilowatt containing 1 kilogram of water is switched on. So 3 kilowatt power electric kettle, 1 kilogram water is there in that kettle, and it is switched on. If the specific heat capacity of the water is 4200 joules per kilogram per Celsius, estimate the time for the water temperature to rise from 30 Celsius to 100 Celsius. So the power of the kettle is 3 kilowatt, that is 3000 watt or 3000 joules per second, and energy is basically power into time, and mass is given as 1 kg, and the specific heat of water is 4200 joules per degree, and we have to find the time, and this temperature rise is from 30 to 100, that is 70 Celsius. So the temperature input energy supplied to the kettle is raising the temperature of the water. So This is the input energy supplied to the kettle through the electric sources, electric power, and this is MC delta T. This is a temperature. So 1 kilogram water, so mass is 1, specific heat is 4200 joules per kilogram Celsius, and this temperature is 70 degrees Celsius, and this power is basically here 3000 joules per second. So we will see this, this joules will cancel with this one, and this kilogram will cancel with this, Celsius will cancel with this one, and this values will automatically adjust, and we will get this 98 seconds. So it will take 98 seconds. So this 91 second is basically 1 minute and 38 seconds. Some of the temperature will be loose in the electric kettle and it will be radiated outside. So we assume that no heat is rejected. So in this problem, we have assumed that no heat rejected. All heat is supplied to the electric kettle is transformed into the raising the temperature of the water. So that's why with this assumption we have this answer, 1 minute and 38 seconds. So, but in this case some energy will be lost also in the real problem, in the practical problems. But for this problem we have assumed some ideal condition. All the energy supplied is used in raising the temperature of the water. So this much time will be okay. So this is the energy supplied, and this is energy gained by this water inside the kettle. Now a metal sphere of mass 100 grams is heated to 100 Celsius and then placed in 200 grams of water at 20 degrees C. So this mass metal sphere is this much mass heated to this temperature level and then placed in 200 grams of water at 20 degrees Celsius. If the resulting temperature of the mixture is 25 degrees C, what is the specific heat capacity of the metal if that of the water is 4200 joules per kilogram per Celsius? So the mass of the sphere is given 100 grams, that is 0.1 kg, and mass of water is 200 grams, that is 0.2 kg, and the temperature of the sphere is 100 degrees Celsius, and the temperature of the water is 20 degree Celsius. Mixture temperature is after inserting the metal sphere into the water, the mixture temperature is 25 Celsius. So in this case the metal is heated at this temperature and inserted into the water, so it will lost energy, so it will lose lost heat. The metal lost the metal sphere will lost the heat, and the water will gain the heat. So the metal lost heat is given as the mass of a metal sphere, the specific heat of the sphere, and the temperature change in the sphere, that is from 100 to 25. From 100 to 25 in the sphere, metal sphere, this temperature change is equal to heat gained by the water is 0.2 kilogram water. This is the specific heat of water, and the temperature rise from 20 to 25. So this is 5 degree rise, and here we have 75 degrees. So from this CS is obtained as 560 joules per kilogram per Celsius. On solving this, we have this specific heat of this sphere metal. This is very, very important. So one of the object is lost the heat, and the other one is gain the heat. Because its temperature rises, so it's gain the heat. Its temperature drops, so it lost the heat.